Hello, and thank you for attending today's webinar, What the Hell is Data Science? I'm Casey Ramage, Vice President of Marketing for EdjAnalytics. Today's presentation is expected to last around 25 minutes. If you have questions during the presentation, please use the chat box and we will answer them at the end of the webinar. At the conclusion of today's event, we're excited to offer you a free data consultation. Using our custom data value calculator, we will discuss your specific business needs and make sure there is valuable ROI for your organization based on your specific challenges and goals. Your host for today will be Sales Manager Zach Pennington and Data Scientist Sean Ferris. I will now hand it over to Zach. Thanks.
Thanks, Casey. So before we get into all the nitty-gritty of what data science is, I think it's actually really important to ask ourselves, why does data science matter? And why do we need it? So let's start with the understanding that making good decisions is actually really difficult. Part of why it's so difficult is when the subject matter is either really complex or the decision is really important, we make bad decisions. So whether you're making a decision about your own personal health care or financial decisions for your company, or maybe you're making educational decisions for millions of students, either way, it can be pretty hairy and pretty difficult to make a good decision. Part of why it's so hard to make a good decision is because that most people typically lack good information. And when we lack good information for making a decision and have to make a decision, we often rely on biases or ultimately go with our gut. So to me, the reason that data science is so important is essentially because it allows us and enables us to make better decisions. We can use better information, more timely information, and more objective information. So now that we've talked about why data science is so important, let's talk about what exactly data science is. So data science is combining the scientific method and a variety of skills from multiple disciplines to extract knowledge and insights from data. And the insights, and more importantly, actionable insights piece is what's important, and we'll focus on that throughout the presentation.
Right, and so who are data scientists? So data scientists typically come from a very wide array of backgrounds, including, but not limited to, mathematics, computer science, natural sciences, statisticians, and also there's a very eclectic set of backgrounds and industries of which data scientists work in. And really, I would say the uniting factor of what comes into play from a background point of view is really anything that allows one to be scientific with the underlying data that we work with.
Yeah, so when we're talking about analytics as a part of data science, we really think it's helpful here at Edge to break analytics down into 4 different levels. So the first level is the data itself. What information do we have? So this could be the data that you or your company has collected, or this could be other third-party data or possibly publicly available data. But knowing what data is there is what you have to build upon as you move through and go up the levels of data science. Now, level 2 is what we would call descriptive analytics. Sometimes you also hear that referred to as historical analytics. These are essentially analytics that tell us what has already happened or what's currently going on today. And we like to group these 2 levels together. This is what most people think of when they think of analytics. So we call this our data analytics group. Now, for me personally, I think where things start to get really interesting is as we move into levels 3 and levels 4, which is what Sean's going to talk about.
Right, and one thing to think about is as we move up really these levels, that's where we come more into the science part of really what we do. And so the next sort of level up from descriptive analytics or descriptive modeling is predictive analytics. And at a high level, this is simply answering the question, what is likely to happen? So typically we try to answer this question by using data to determine, okay, what has happened in the past? What are the patterns related to that? And then how can we use that to have some estimation on what is likely to happen in the future? And that sort of leads us to the top level, if you will, which you can kind of think about as the goal of analytics. So given that we have some good model or understanding of some event that is likely to happen, or some information on forecast or anything like that, what do we actually do with that information? So knowing what is going to happen and then knowing what to do about it are 2 different things. And so really at this level, we're focusing on putting those insights and those predictions into action. A super easy way to think about, the 2 areas of predictive versus prescriptive modeling within data science is correlation versus causation. All right, so again, predictive, we're trying to find those patterns in the data, and then prescriptive, we're trying to actually find the causal effect. So what do we actually do about that?
Awesome, thanks, Sean. So next we're going to kind of go into more depth on each of the tiers just to help understand them better and ultimately how they're all related. So first off is the data itself. So data is simply a set of values of qualitative and or quantitative variables. So if we were to collect some data points on Sean here, we could say his age is 27 years old, he's male, his job title is data science, and he's handsome. A lot of people like to throw around the term big data, but all that simply means is data sets that are so large and complex that traditional processing and storage is inadequate to handle those data sets. So Sean, what would be a good example of a big data set?
So Facebook is a perfect example. Really all of the collective data that they collect on all of their 2 billion plus users, or however many that's up to now, the data that Google has for search history is also a good example of truly big data sets.
Awesome. So when we think about data, we also think about breaking it into two main types of data, which would be structured and unstructured. So structured data is information that's highly organized, it's consistently formatted, and it's relatively easy to filter or sort through. So a good example of this might be if you had a spreadsheet of all of your company's products, and it would include their cost, their price, the SKU, maybe the color, maybe the inventory. It's a consistent formatted data set that you can sort through easily, and it's really easy to process structured data. Now that's different from unstructured data. Sean, tell us about that a little bit.
So unstructured data is exactly the opposite. There's a lot of information contained in this data, but it's not in a form that is very easy to use. So it could be very disorganized, it could be inconsistent, or just simply put plain and hard to filter or to sort. So there's a bunch of different ways that this could happen. So one is text data, right? I mean, if you were to analyze the text of your emails, text data, there's a lot of information contained in that, but it can be challenging to work with. You also see this in medical records with handwritten doctor's notes, or even working with photographs is another example of unstructured data.
Awesome. So moving up to level 2 is descriptive analytics, or as I mentioned, historical analytics. So that's essentially processing this raw data into usable information, typically through tables, charts, graphs, things that help you visualize, sort, and classify this historical data. So probably the most common example that many of you are familiar with is the Google Analytics tool. Their tool will tell you how many people have visited your website, which pages they visited, and for how long, maybe what sources they came from or what countries they're located in. It gives you a ton of really interesting information about the past behavior of your site visitors. And when most people think about the word analytics, this is typically the type or level of analytics that they're talking about.
Right.
However, when we're here at Edge, when we think about analytics, we really get more excited about the next two levels, which are predictive and prescriptive analytics.
So moving up the levels, so the next one to discuss is predictive analytics. And again, this is simply trying to use historical data to have some understanding on events that are likely to happen in the future. So an example of this that we have done here at Edge is building a model for a local university to predict freshman to sophomore year student attrition. So high level, this is simply given a freshman on campus, what is the likelihood that they will not return for their sophomore year? And again, the big difference between predictive analytics and descriptive analytics is we don't want to just simply look at historical data, but rather we want to learn from historical data and use that to determine what is likely to happen. So we can see here, basically we built a model that predicts the overall risk as a percentage for each student to not return to campus the following year. And what we did with that model was we rank ordered the students into 5 groups, right? So group 5 would be your highest risk students, group 1 being your lowest risk students. The thought there was if you have a finite amount of resources or a finite amount of these students that you can actually make an interaction on, you might as well target the students that are at the highest risk of leaving. And so to the right here, we see the prediction model. So basically that was what our model was predicting in each of those groups. What would the student attrition be? And on the right, we see what the actual values were. So an important thing to think about here is, again, the column on the left is the output of our model, and the column on the right, so the Bellarmine actual, is what the new data looked like. So again, this was data that our model had not been trained on. So this is really allowing us to get ahead of the curve a little bit.
And what's interesting here from my perspective is that now the university can be proactive, like Sean said, and intervene with these students before they leave. And so given that each student represents tens of thousands of dollars in lost revenue, it's a really important problem for them to get ahead of instead of just being reactive to it, which is what they were doing prior to this.
Exactly. And so really the mechanism by which we do a lot of this predictive modeling, how we actually build these models and find these patterns, is this notion called machine learning. So when you first hear machine learning, it sounds very sort of futuristic and complex, but simply put, machine learning is the application of mathematics, computer science, statistics to data in order to determine patterns. And that's really the sort of the high level view of what's going on with it. And one way to think about this is in relation to how people learn, right? So people learn from experiences. And traditional computer programming is in which we are explicitly telling the computer what steps to follow. And the differentiating factor of machine learning is that we are actually building these applications to learn from the data on their own and find those patterns from the data itself.
So a good example of machine learning many of you might be familiar with is when you go on Amazon and they have those recommended items for you to purchase. So there isn't really a person sitting at a desk trying to figure out what you should buy next, but rather there's a machine learning algorithm that's analyzing past customer purchase behavior and then marrying that pattern to your current behavior to learn to ultimately predict what you're likely to need next. So if you bought a phone case, maybe you're likely to need a charger. If you bought a camera, maybe you're likely to need a camera bag, things like that. And they can do that using not their own assumptions, but actual evidence inside of the data.
Exactly. So the next question is, okay, how do we actually go about doing machine learning? How does machine learning work? Well, probably not too much surprise, it does all start with the data. One interesting thing, though, is that we don't always use all of the data to train our models. So the first thing that we always do is we split or we group the data into two groups. One being what we call the training data, the second being what we call the holdout data or the test data. And the difference here is the training data is what we're actually using to allow our models to learn. Whereas the test data, we don't let the model look at that. And so our use of the test data is to emulate the actual use case of our model, right? We want to build these models to work on new data sets. So that's what we use this test data for, to really evaluate how our model is going to work on data that is not necessarily seen before. Another interesting aspect here are labels. So this is really about outcomes. So going back to that Bellarmine example, we could have a lot of data on the freshman students that we wanted to build a model on, but we also needed to know the outcome, meaning did this student actually return for their sophomore year or did they not? So we call that labeling the different observations in our data set. So in that case, labeling whether the student returned for their sophomore year or not. And it's really this, again, this training data that we use in the various machine learning algorithms that are out there today to develop these models. And the output of this is a predictive model. And again, you know, how we evaluate whether or not a model is good or not, we use that test data to evaluate that on the algorithm itself. So that's an important factor, is that we try to use that data to, again, emulate that actual use case of how we want to use this model, because then we want to use this model on new data. So back to that Bellarmine example, we want to use this model not on previous students, but on this year's students or next year's students, right? And so that is kind of how we go about this typical process of generating these predictions for the variety of problems that we work on.
All right, that's awesome, Sean. So next we're going to talk a little bit about prescriptive analytics, right? Because having information is great, but if you don't have an action to take on that information to make a better outcome in the future, it's only so valuable. So
Exactly. So this is sort of the final level of analytics, if you will. And what I think about is the goal of analytics, right? So again, this isn't simply knowing what is likely to happen, but it's also taking it a step further and having some actionable insights, something that you can do to influence that outcome. And it's really about trying to establish causation and develop rule sets around how you act on these things. And so a couple of examples of how we've done that at Edge, or how we are also sort of developing these models to really go from that predictive level up to the prescriptive level. One is an example that we've done with a healthcare provider in Philadelphia around congestive heart failure. So we're predicting 30-day readmission risk for congestive heart failure patients. And we see here at the bottom of your screen, this is essentially the output of our model. We have, for each patient in these cohorts that we analyze, we have their risk of being readmitted to the hospital. And so you can see that there's a lot of information associated with that. On the left, we have essentially what does their risk look like over the course of their stay. And we also express that relative to not only the individual patient risk, but also the risk relative to the overall population. And so for this given patient, we can see that they have an extremely high % chance of being readmitted to the hospital. So the next question is, okay, given that this patient is such a high risk, what do we do? How do we influence that outcome? And it really becomes a study at that point of how do we actually take this information and prevent this readmission from occurring in the first place.
All right, so some of you might have heard about our Philadelphia Eagles work that we did and our small but important contribution to them winning the Super Bowl. So Sean, can you walk us a little bit through how we actually helped them? You know, I had a lot of people messaging me say, hey, did you tell them to do that trick play? And as much as I wanted to take credit for that, I knew better not to. So talk a little bit about how our football simulation tool works.
Yeah, of course. So I think of what we've done in football, again, is sort of the culmination of all the levels of analytics. I mean, it's really all rolled into one. I mean, you have the descriptive analysis, the predictive side of things, but then we're also recommending actions based off of that. So when you think about a quintessential decision in football, it's, you know, do you go for it or not? And so basically the way that our model run is, as we see here, this is a situation in the Super Bowl, and we see that, you know, the Eagles were scores 33-32, and, you know, gives you the different scenarios of the game. And again, to the right, we see the actual prescriptive output of our model. So we're not simply saying what is likely to happen if they were to go for it, if they were not to go for it. We take that information into account, and we also recommend what they should do. So we see here that a short pass is the optimum result, or rather the optimum decision to go for it, relative to, for example, punting or kicking a field goal. And another thing to think about here is that this is all in the metric of game-winning chance. So we're really focusing on what is the true goal of a decision. So in football, it might seem like, you know, the goal is to simply get a first down, but what our model takes into account are how these decisions lead to different probabilities of actually winning the football game. So that is the actual goal of the model, not necessarily getting a first down.
And one caveat here, at the end of the day, the coach and the players still have to take these actions, and they have to use this insight, right? So they have to run the right plays, have to throw, run, catch the ball, and do all that. However, at that level where they're performing, it's really the ability to increase their strategic decision-making quality. That's what gives them an edge over the other teams, right? So that's why we saw that work so well with the Eagles. They're not just a great team, but they actually adopted the methodology from top to bottom. And that's what's really important about having data science integrated into your organization. So I know what I do all day, Sean, but I think the audience is probably curious, what exactly do you do all day?
Yeah, of course. So I would say at a high level, the process is roughly made up of maybe 5 or so components. And it really all starts with defining the problem at hand. And the way to think about this is if a client comes to us and says, you know, I want to predict risk for CHF readmission or student attrition, it's translating that business problem or that industry problem into a mathematical or statistical problem. And it's also thinking about what data do we think is available to support making those predictions. Because if you don't have a lot of data or you don't have the right information to make a prediction, then even the most complicated model isn't necessarily going to have a good outcome. And that sort of leads into the next step of actually collecting the data and preparing it. So oftentimes, how we end up doing this is we work with client data. So we have a process of obtaining that data or getting access to that data, and then we start the process of preparing it for modeling or machine learning. And that's a pretty involved process at times, depending on the quality of the data, how much data is there. But at a high level, it's really about taking into account things like missingness, like if you have missing data instances or variables, handling anomalies or outliers, things of that sort. And the next step is what I consider to be the good stuff, right? So that's when we're actually building our models. And that kind of goes back to that how does machine learning slide work that we discussed earlier. And that's typically the process that we take in terms of, okay, we have the data, we've done all of our preparation, now let's actually start putting it in models. And again, we're trying to evaluate and test that on that unseen data to see how good we're going to do on the new data whenever the model is put into production. And the fourth part is model deployment. So that takes a variety of forms. That is essentially how do we deliver our insights to the client. So that could be workflow integration. We could give them an application around our model, or it could simply be a presentation or a study related to that. I mean, that really depends on what the client wants, what the client needs, industry, and the actual problem at hand. So there's a lot of factors there, but that one's really about how do we actually take this model and make those insights available. And the last part is improving the performance. So that's a big one. That's just making sure that our models, predictions, and those patterns that it's finding in the data are holding up over time, making sure that there aren't changes in those patterns over time. You know, things like that to just ensure that our model will continue to work at the highest standards. And this thing really does, this typical process does form a bit of a cycle because it is all very iterative, again, because things do change over time. Data availability changes over time. And so that's a big part of making sure that our models stay effective is to kind of revisit this cycle as a whole.
All right, so you might be wondering what type of software, tools, languages, et cetera, do data scientists use? And many of you might be familiar with these or heard of them or seen their names before, but you might not know exactly what they're used for. So Sean, could you break these down a little bit for everybody?
Yeah, absolutely. So there are a ton of options out there, which is both a good and a bad thing. So, I would say the biggest ones that are used by data scientists are the top three that we have listed here, R, Python, and SAS. So those are your scientific computing or modeling languages. So when we're doing machine learning or we're doing statistical modeling, those are the language in which we're actually carrying out those things. But there are a wide variety of other options, such as MATLAB, and then of course Java is just a general purpose programming language, which you can also use in this way. But then you have things like Hadoop or Hive, which are big data tools. So if you have lots and lots of data, so going back to the example we talked about earlier of Facebook or Google, when you have data at that level of size and magnitude, you need tools that are very fast and efficient for working with those. So those are examples of those big data tools. And then you have SQL or SQL, and there are lots of different flavors or versions of that. And SQL is really just about maintaining the actual data, accessing the data, moving it around, processing it. It's really about getting at the source of the data itself.
So we've been talking about science this whole time, but to me, I think data science is also a bit of an art. Something I've learned since joining the company is that even though the input and output data are relatively objective, it's that methodology of finding insight within these large data sets that really sets a data scientist up to be a bit of an artist, right? They have to take risks. They have to have a perspective. There's a lot of trial and error. and a lot of instinct that go into deciding which things to process, how to tackle the problem, where to look first, and really how to improve.
Yes.
So we're pretty close here to the end. What I want to ask you all to do, these are kind of rhetorical questions, but I want you to think a little bit about what we've talked about today and how that applies to yourself and the organizations you all belong to. So first question I'd ask myself is, what data do I have at my organization or at my disposal? So how large are these data sets? How long have you been collecting them? Are they complete? Are they incomplete? Like, how high quality are they? Because if you know that you have a large or high quality data set that you've been collecting for a long time, then you're a really great candidate for applying data science to that. Whereas if you're just getting started, then it makes sense to think about what is my goal in the future and how could I collect that data differently so that I can eventually use data science. And then another question I'd ask myself are, what are kind of the biggest assumptions or hunches that you have about what's going on within your organization or the problem that you're trying to solve? And how could you use data to prove yourself right or possibly even prove yourself wrong? You know, we've worked with people before where they assume one thing to be the case and our model or our data has shown the opposite. And it takes a lot of humility to admit you're wrong or to be proven wrong by the data. But if your real goal is to improve your outcomes and make better decisions, you're going to do that. And that's, again, that's the work we've seen in our clients is they really take a step back and allow the data to speak its truth. And so ultimately the question here is, how could data science help you solve those challenges, right? So whether it's a sales and marketing challenge, maybe you have HR or operational challenges or financial challenges, think about what could data science do inside of your organization to make things a lot easier and more effective for you all.
Thanks, guys. We will now take some answers. We'll now answer our viewer questions. And our first question today is, what would I actually be receiving for my budget?
Yeah, that's a great question. And that, thinking back to that process of what we talked about, what does a data scientist do all day and really model deployment? It really just depends on a couple of factors. One is the problem in hand, but I think more importantly, it's the client and what do you actually want to do with that? So this is something that every project that we've worked on has been different. And again, it's just very dependent on the needs of the situation. So, a couple of examples, the football product is a cloud-based platform. So, you can just kind of, if we have a team that is interested in purchasing that, we can just kind of turn that on for them and they're good to go. With the CHF readmission model, we actually worked with the hospital system to integrate our model into their EMR. So essentially now we're putting that information, that science in the hands of the clinicians themselves. So anytime they're working with one of their patients and they can see their previous diagnoses, their lab values and vitals, they can also see the output of our model as we showed. So it's really about understanding how do they actually want to use the model and when does it make sense to really put those insights into action.
Great, thank you. And our next question is, when working with football and hospitals, we obviously have access to large sets of data. What do you do in the case where you don't have access to that? Say you're looking at a marketing strategy.
Yeah, so that's definitely a big challenge for a lot of our clients is they want to make these predictions and they want to understand the potential of these future outcomes, but they don't feel like they have either enough data or a long enough data set. And what I like to do is I like to be a little creative and try to find either proxies for or other data sets within their organization that might be valuable. So say, for example, you might not have a ton of marketing data. Maybe you haven't been using email marketing software very long or a CRM or anything like that. But you might have a ton of transactional data from your customers historically. So we can actually look at and mine and model that sales data and then come up with marketing hypotheses to build on top of the sales model. So if I know that customer A is likely to buy product X, every 6 months, and I've built a model for that, now I can start to think about how do I market product Y, right? Because product Y is actually a good fit for them based on our model, but I don't have a marketing strategy yet for that. So it's really about working with the data that you do have. And then obviously if you can engage a company who's good at database management, managing your data going forward, you can actually start to think proactively about how to build those models so that 6 to 12 months to 2 years from now, you actually have really good actionable data. the guys here and the team here are all about the more data, the better, but we've definitely worked with some relatively small data sets and still been able to find insights. So you'd be really surprised.
Thanks, Zach. Our next question is, does Edge typically produce and report on models, or do we work with companies to help them gain the skills internally to work with future data science?
That's a good question. So I would say it's typically the former. So typically we are kind of acting as a sort of outsourced data science team for our clients. That is something that we have considered in the past and done some of that. I can say that the majority of the clients we work with do have analytics departments or teams within their organization. So it could just be bringing in our sort of unique skill set of the sort of the data science side of things or the modeling side of things. It could just be extra resources, right? I mean, we do work with clients that have data scientists, and our sort of value proposition there is just giving them more bandwidth to take on more projects and to really leverage all of the information that these different companies have contained within their data.
Great, thanks, Sean. I think we've got time for one more question, which is, how do I know if my data is good or if there is enough of it?
Yeah, so that can always be a challenge. And one thing that we've found is typically people who think they have a lot of really good data might not, and people who don't think they have enough do. So I think there's a data illiteracy or a lack of data understanding on how valuable your data might be. And so I think that's why it's important to engage with analytics and data science firms, because we have a more objective perspective on how much data you have and whether or not there's potential value in there. It's something that's been really traditionally hard to value. But if we can work backwards and kind of figure out the value of the problem we're trying to solve, for example, with the Philadelphia Eagles, winning the Super Bowl has a tremendous amount of value. So if we work backwards from there and say, okay, do we have enough data to help you do that? Then that helps you decide whether or not you should pursue data science more so than the individual data itself. But that's a really great question.
Thanks, guys. That concludes today's webinar. We really appreciate everyone attending. We look forward to discussing your goals and how data can help drive better decisions for your organization. To schedule your free data ROI session, please contact Zach directly at zpennington@edjanalytics.com. Today's session will soon be archived on our website. Thank you and have a great day.
Thank you.
Thank you.